All right, so let's start by solving for theta. And the directions will either tell you to solve over an interval, and they'll tell you to solve over the interval of 2 pi, or it'll say, or 0 to 2 pi, excuse me, to solve or find all solutions. So we'll do both. Let's start by solving over an interval. And the equation we'll start with is 8 cosine theta minus, or plus, excuse me, 4 square root of 3 equals 0. Okay, so if I'm solving over the interval, the first thing I want to do is get cosine theta by itself. So we'll take that 4 root 3 to the other side. And then I'll divide by 8. So finally we have cosine theta is equal to negative square root of 3 over 2. Okay, and that square root of 3 over 2 should look familiar to you, right? That's what comes off of one of our special angles. So if I keep that in mind, so that's where that little cheat sheet comes in handy, right? The square root of 3 and the 2 come from that 30, 60, 90 triangle. So when is cosine, or adjacent over hypotenuse, square root of 3 over 2, that would be when I'm looking at that 30-degree angle, or, where is it, pi over 6 radians. So what I would do is think, okay, so this tells me that the reference angle that I'm interested in comes off of that special triangle. So the reference angle that I'm interested in is pi over 6. Since this is negative, I have to consider which quadrants is cosine negative. So that would be in quadrant 2 and in quadrant 3. So I'm looking for the angle in quadrant 2 whose reference angle is pi over 6. I'm also looking for the angle in quadrant 3 whose reference angle is pi over 6. So if you think of pi as 6 pi over 6, then I can easily see that this angle would have to be 5 pi over 6, and this one 7 pi over 6. So basically what I just realized is that cosine of 5 pi over 6 is negative 3, or negative square root of 3 over 2. And cosine of 7 pi over 6 is negative square root of 3 over 2. So the two angles within one revolution, or from 0 to 2 pi, for which this is a true statement, theta is equal to 5 pi over 6 and 7 pi over 6. So that's the solution. Now, if the directions had said find all solutions, and if you think about it, right, we know both from thinking about the unit circle and also by thinking about the graph of this function that there are an infinite number of values for theta for which cosine of theta is negative square root of 3 over 2. So really, we have this is the first angle we would come to, but then from here, I could continue to add 2 pi forever. And cosine of that angle would also be negative square root of 3 over 2. So what we do to express all solutions, I would say theta is equal to 5 pi over 6 plus the next one would be adding 2 pi. I could also add 2 pi again. I could add 2 pi again. And I could do this forever and ever. The condensed way to say that would be theta equals 5 pi over 6 plus 2k pi, where k is an integer. And the shorthand set theory way to say that is that k is in z. This means k is an integer. So that basically means that I can continue to add 2 pi forever or subtract 2 pi forever. Now I would do the same thing with the 7 pi over 6 angle. So theta can also be 7 pi over 6, and I can continue to add or subtract 2 pi forever. So these are my solution sets.